Hi, and welcome to the order of operations with fraction bars. Let's go ahead and get started by reviewing the order of operations. So, the very top, the very first step is going to be grouping symbols. And grouping symbols include things like parentheses. And you may be looking over here going, GEMDOS? GEMDOS? I learned PEMDOS. That's supposed to be a P, right? Well, in elementary school, really the only grouping symbol that you dealt with was parentheses. And so that's why you probably learned that with a P. And you probably are going, I don't understand what this G is. Well, the thing is, we call parentheses grouping symbols because they group numbers or group letters together. There's a lot of other grouping symbols out there, and we're going to be using them this year, including one called a fraction bar. And so if we left this as a P for parentheses, that doesn't really encompass all the stuff that it needs to. So we need to use a broader term, and we need to use grouping symbols because we're going to be doing things like fraction bars, and there's going to be other ones throughout the year too that we're going to use. And so I want you to start thinking about this first step as a grouping symbol step, because otherwise you're not going to know where to put it. You're going to get a fraction bar and you're going to go like, where does that go in the order of operations? I have no idea. All right, so if we take a look at the next one, next would be exponents, so we're going to evaluate exponents. And then multiplication or division from left to right, and it's whichever one comes first. So if multiplication's first, you do multiplication. If division's first, you do division. The same thing with addition or subtraction. If I do addition first, then if it comes first, and I do subtraction first if that comes first. And you're probably going, okay, well, why are these two on the same step? And why are these two on the same step? Well, that's because these are what we call inverse operations. Basically, they're the opposite of each other. So if I have the number 5 and I multiply by 3, 5 times 3 is 15. If I divide by 3, 15 divided by 3 is 5. I'm back where I started. So they undo each other, and they act the same way when we're dealing with stuff. And the same thing with addition and subtraction. They're inverse operations, and so a lot of their characteristics are the same. And then so that's why we're going to have it on the same step, because it's going to act the same way. Alright, so let's go ahead and take a look at this problem. You can see that this is a fraction bar, and I've already told you it's a grouping symbol. And that's important to know. And basically, here's the deal. First of all, don't get intimidated by this word fraction. Fractions are not scary. Even if they were scary in the past, I don't want you to get scared of them because really they're not that bad. We'll take care of it this year. Alright, if you take a look, what it means is basically, I've got these imaginary parentheses, you can think of it even. I'm grouping the top together, and I'm grouping the denominator together. So the numerator, okay, is one expression, the denominator is another expression, and then I'm going to divide it. You can think of it that way. Really, it's kind of like I've got two separate problems, and then I'm going to divide it, even though it is one big problem, okay? But in order to, when you're evaluating it, you just want to think about it as two separate problems. That's okay to do that. So basically we have to do the numerator first, and then the denominator, and then divide them. So if I look at the numerator, the parentheses, well, the grouping symbols, they're kind of grouped together already. I don't have any extra ones. So then I take a look at exponents. And so 3 squared would be 3 times 3, and we know that because this means 2 3's multiplied together. So 3 times 3 is 9. And I haven't used the minus 4, so I'm going to bring that down. Alright, if I look at the denominator, I don't have any exponents. I do have multiplication or division, so I have multiplication in this case, so that's what I'm going to do first. So 2 times 3 is 6. Bring down the 7 minus because I haven't used it, and then subtract across. 9 minus 4 is 5, and 7 minus 6 is 1. And I told you that, I believe before, that that is another way of saying division. That bar represents division. So this just means 5 divided by 1. Okay, that's it. 5. Done. Not so scary, right? Let's look at some more examples. Okay, so if I take a look at this top expression, okay, first thing I notice, it's got a fraction bar, which means grouping symbols, which means I have to evaluate the numerator and evaluate the denominator before I can divide them. So the first thing I look in the numerator, it doesn't have any grouping symbols in the numerator. It doesn't have any exponent, so that means multiplication, division. And as I go across, the first one that I come across is that 16 divided by 2. And 16 divided by 2 is 8. And I haven't used the times 4 or the 18 plus, so I'm going to bring that down. Okay, if I look at the denominator, I don't have grouping symbols, but I do have exponents. So I'm going to deal with that 4 squared. Remember, that means 2 4's multiplied together, which is 16. I'm going to bring down everything I haven't used. Okay, going on, Numerator, I don't have any exponents, so I'm going to be doing multiplication. 18 plus 32. Okay. And down here, again, I don't have any more exponents, so I'm going to multiply. And 13 times 2 is 26. And then we're just going to finish up the problem. 18 plus 32 is 50. And 26 minus 16 is 10. And remember that bar means to divide, so 50 divided by 10. It's just 5. And that would be my final answer. Okay? Let's look at this example. Again, I noticed the fraction bar, so I've got a grouping symbol to deal with. And I can see that within that I have to do the numerator first and then the denominator, and then I'm going to divide them. Exponents come before subtraction, so 7 squared means 7 times 7, because remember it means 2 7s multiplied together. That's 49. I'm going to bring down my minus 1. Okay, moving down to here, I can see that I've got multiplication and division, and so it's whichever one I come to from left to right, and the first one I come to would be the 20 divided by 5, which is 4. Okay, 4 times 3. So I just have one operation left in both, so I can go ahead and do 49 minus 1. It's 48, and 4 times 3 is 12. And when I divide it, it comes out to 4. All right, your turn. As long as the boards don't attack me, that's good. Okay. So here's the deal. What you're going to do is in a moment you're going to pause the video. I'm going to give you a chance to go ahead and work those out, and then I'm going to go back through and make sure that you understand how to do it correctly. You can check yourself and that sort of thing. So you're going to pause it right now so that you can go ahead and try those. So go ahead and pause it. I'll wait. Okay. So, did you really pause it? I hope so. Got to try those problems. Let's take a look. Fraction bar means a grouping symbol, which means I have to evaluate the numerator and I have to evaluate the denominator. So I'm going to start by evaluating the numerator. Okay, I don't have any other grouping symbols, so I need to do my exponents. And so that's going to be 8 squared. And 8 squared means 2 8s multiplied together, so 8 times 8, which would be 64. And then on the bottom, I also have an exponent. I didn't have any grouping symbols, so 2 squared means 2 2s multiplied together. And so 2 times 2 is 4. Okay. When I take a look at the numerator, I've got multiplication, which has to come before addition. So I'm going to go ahead and do 4 times 5, which is 20. And on the bottom, I'm all done. I got a 7. No big deal. It's okay that I finished here, because sometimes the numerator and the denominator won't be the same number of steps. So I'm just going to go ahead and add those together, which gives me 84. And I just bring the 7 over, because I've already done everything I can in the denominator. Remember that bar means division, so the last step is going to be 84 divided by 7, which hopefully you know your multiplication facts through 12, so you can tell me that that's 12. Okay? All right, last problem. Again, I've got a fraction bar. So that means that the numerator has to be done and the denominator has to be done, and then I'm going to divide. So looking at the top, I don't have any other grouping symbols in the numerator, so I'm going to move to the exponents, which I don't have any of those either. So I move down to multiplication and division. I don't have any division, I just have the one multiplication, so I'm going to do that first. 3 times 15. If that's something you can't do in your head, remember you can always go off to the side and do it over here so it's out of your way. You just don't want to do it in the middle of your problem because it makes it confusing. But 3 times 15 is 45. Okay. Down here, I don't have any grouping symbols, I don't have any exponents, I don't have any multiplication or division, all the way down to addition or subtraction. And it says whichever comes first from left to right. And so I happen to hit subtraction first. So 12 minus 11 is 1. Okay, I'm going to go ahead and add these two together. So that's going to come out to 64 divided by 2. And my final answer, 64 divided by 2, is 32. Again, if you needed to do the division out, you can do the division out. Just don't do it in the middle of your work because it'll make it a little bit more confusing. All right, I hope this helps with how to evaluate order of operations problems that have fraction bars in it. And if you need to, remember you can always watch the video again.